All right, welcome back, everybody. It is noon Eastern. We are going to go ahead and get started. This next session is an Incubatenergy panel. So we're going to show you a quick snapshot of 5 of our Incubatenergy companies. We're really excited to have this panel. As a reminder, please use the Q&A and chat to ask any questions or comments. The presenters, after they speak, will be able to engage with you there. And if we have time at the end, we would love to get to those questions. All right, I'm going to hand it over to Eric Stieb from EPRI, who's going to be our session moderator. Eric, over to you.
Thank you very much, Hannah, and welcome everybody. Thanks, Hannah. Welcome everybody. It's excited to be here as part of this AI reverse pitch event. I'm Eric Stieb from EPRI's Technology Innovation Group and run a program called Incubatenergy Labs and a network of incubators and accelerators called Incubatenergy Network. I'm excited to present a little bit about what that is, to give you some background, but more excited to share with you several of the projects that one from last year and several from this year that we're teeing up, some demonstration projects that are AI related that we're really excited about. So happy to share those with you today. So thank you again for joining. Incubatenergy has been around since 2014. There are 2 aspects to this today. One is a network of independent incubators and accelerators that we work with to engage clean energy startups around the commercialization of their sustainable energy-related technologies. And the second we've built on top of that is Incubatenergy Labs. This is a open innovation program where we link startups with our EPRI utility members to demonstrate and scale their innovations in decarbonization, electrification, grid modernization, resilience, all these things that we need to deliver to achieve deep decarbonization by 2035 in the electric power sector. So I want to talk to you about both of those things. First is the network. This is a network that was started with some DOE funding way back in 2014 around helping independent organizations commercialize early stage technology. So these are incubators and accelerators that work with startups in communities around the world. This is predominantly North America focused, as it started with DOE funding, but we're now expanding this to include Europe, Middle East, Asia, and Latin America. There are about 45 incubators and accelerators in this network today, and we continue expanding each year. The focus of this group is really sharing best practices in commercialization and sharing opportunities for the startups in these networks to participate and get opportunities to commercialize their technology. Hopefully, you're in one of these areas in the country where you can connect with these types of organizations. If you're interested in finding out about this network and the organizations in this network, you can check out incubatenergy.org website, or feel free to chat me or send me a Q&A right here on the platform, and I'll get back to you. On top of this network of incubators and accelerators, we've built a rapid demonstrations program to find innovations that help us achieve deep decarbonization, connect those innovations with our utilities, and test them to understand their feasibility, efficacy in our electric power infrastructure, and help scale those solutions into market. This is a collaborative scouting and demonstration program run with a number of utilities. Right now, there are 15 utilities participating in this effort. You can see them on the right side of the screen here. We are all about testing and demonstrating new solutions in the areas that I had mentioned, focused on specific innovation priorities where these group of utilities and EPRI are actively investing, researching, and demonstrating these types of technologies. It's built around a 5-phase process, where we first identify what those specific technologies are. We send a communication out to the startup community to apply for paid demonstrations with this group of utilities. We then go through a period of due diligence with the companies to really understand their solution and what a rapid demonstration might look like, to learn about some of the key unknowns of including these technologies in our marketplace. And then finally, we run 16-week rapid demonstrations with the companies. These are all paid demonstrations for these startups. So this is early market traction for them and gives them great exposure to our EPRI members to get their solutions to scale. That scale aspect is important because, as I mentioned, we're all targeting deep decarbonization in the sector by 2035. It really requires a strong collaborative engagement and rapid assessment of these technologies to help facilitate scale of those solutions. From a utilities perspective, they really like it because they get to engage their peers on driving their innovation priorities. They can leverage the crowd. It's their own subject matter experts and EPRI subject matter experts every year that go through the screening of the companies that we see. And then finally, it's collaborative engagement on demonstration projects. So each one of these companies that you'll hear from engages one of these utilities in a lead project, and the rest of the utilities follow along very closely to understand the progress of those projects, the key learnings coming out of those projects, and they get the opportunity to engage these utility teams. It helps these utilities and EPRI build our capacity for rapid learning and innovation scouting, ultimately helps us expand our innovation capacity. From a startup's perspective, obviously this is a great resource because you can engage many utilities at the same time. This is early revenue for these companies. It provides broader exposure to all of our members. Our demo day that's coming up in October is open to all EPRI members to learn about the projects that we've run. And then finally, for these startups, we create the collaboration across our utilities to create this environment where success with one of them results in traction with many of them. The challenges that are underway today, we launched these back in December and invited these startups to apply. You can see the 7 categories that we are focused on for this year. As we got into this set of challenges for this year, we had a great startup response, 253 startups engaged in the process. We ultimately considered 142 of the final applications. You can see the country breakout here, quite a few of them from the United States, but a good number from the international community. In fact, on the group here today, you'll hear a couple of international companies as well. So really proud of and happy with the reach that we've achieved in this program to bring startups and utilities together. We're in our 3rd year now. We're excited to be working with this many companies. Last year, we ran 10 projects. This year, we're just getting into this phase now of running the demonstrations. We're targeting 18 to 20 projects for our 2021 cohort. And you'll hear from several of them today. So before we get into the actual presentations, I want to remind everybody that you can pose questions to these startups in the Slido chat room right there on your screen. The presenters will have access to those queues. We have just 9 minutes for each one of these companies, so we'll be a little short on time for Q&A, but leave them there in Slido app. The companies will join the platform and can respond to that even after their presentations today. So be sure to send Q&A in that chat room. So with that, it's great to introduce the companies that we are working with our artificial intelligence team at EPRI. These are all projects, with the exception of one of them, which was run last year. These are all projects that we're teeing up to run this year, funded by our AI team at EPRI, but working closely with the utility. So each one of these companies will let you know what they're doing from an innovation perspective and how we're moving forward. So first up in our presentations is Chris Ricciuti. He's founder and CEO of Noteworthy AI. Chris, over to you.
Awesome. Thank you, Eric. And hi, everyone. My name is Chris, founder of Noteworthy AI. And the focus of my talk today is around using computer vision to identify pull-top components and defects, specifically on distribution assets. And we'll focus on how selecting the optimal hardware, such as cameras and lenses, can impact object detection model accuracy. So why inspect distribution for defects in the first place? As we're all very well aware, risks from extreme weather create new challenges for electric utilities around ensuring the reliability, resiliency, and safety of the electric grid. As a result, utilities have begun to adopt mitigation measures that account for these risks. And one type of mitigation focuses on visually inspecting assets at scale and identifying equipment defects that could lead to bigger problems. But while inspecting at scale has been successfully achieved through the use of drones, for example, on large-scale transmission assets, these methods have not been broadly adopted on distribution, leaving it particularly at risk. And so many utilities currently employ methods of inspecting distribution that require dedicated vehicles and crews and are costly, such as grid patrolling inspections. Therefore, they don't scale to a level needed to truly mitigate risk. So how then can you better mitigate risk on distribution? And more specifically, how can you perform low-cost inspection at scale, similar to what's possible on transmission today? One way to achieve this is with computer vision or object detection to automatically identify pole-top components and potential defects on those components. But the real challenge in doing so is not so much which object detection models to use, it's how you collect images of each pole in the first place. So what if you could mount devices which could include a series of cameras and a small computer on existing fleet vehicles? And these devices could capture images of overhead assets and run object detection models right on the device. Then whenever those fleet vehicles are in motion for any purpose, inspection can actively occur. And when you compare this to existing processes such as grid patrols, you can see that a solution like this has the potential to help inspect more assets, reduce time to action, and cut O&M or operations and maintenance costs because you can reduce the number of truck rolls that are dedicated to inspection. But there are certain challenges that might adversely affect object detection accuracy that first need to be overcome. For one, vehicles will be moving, and while the system is active, so motion blur and distortion in the resulting images is a real possibility. Similarly, bumpy roads or loose vehicle suspensions could mean that stability is a concern, and unpredictable lighting conditions could lead to over or underexposed images. And also ensuring that the optimal conditions exist for image capture, so things like not capturing imagery if the vehicle is moving too quickly, can make the difference between accurate prediction or too many false positives or false negatives. All of these issues can impact object detection accuracy, so selecting the optimal hardware that mitigates these concerns is key. So how do we then ensure that all of this works well and that we maximize model accuracy? Well, we can start by reviewing the issues that we identified on the previous slide, as well as some steps that we can take to mitigate each of those. For instance, blur and distortion can be mitigated by choosing a global shutter camera with a high frame rate and not a rolling shutter camera. The difference being that global shutter cameras expose the optical sensor to light in a single shot versus a phased approach with a rolling shutter camera. And as a result, global shutter cameras do a much better job for use cases where motion is involved. And choosing the right lens for that camera, one that limits optical axis shift, and selecting a mount for your equipment that minimizes rubberized components can all help with stability issues. And cameras with auto exposure or at least an adjustable aperture can help to minimize the likelihood of under or overexposed images in challenging lighting conditions. Additionally, one can help to ensure that images are only captured during optimal conditions by leveraging sensor data from accelerometers and gyroscopes, plus leveraging depth or distance data to ensure that pole-top components are physically close enough to the camera before capturing frames. So here's a high-level example of how we utilize various hardware plus sensor data to maximize object detection accuracy in our solution. We start the process on the left at step 1, where we leverage a stereo camera to collect video frames at a rate of 30 frames per second. But the stereo camera also allows us to achieve things like measuring depth, which is useful at later stages in the process. At step 2, we run our first object detection model on every frame from the stereo camera. This model is trained to simply identify whether a pole exists in each frame. If a pole does exist, we move on to step 3, which is where we ensure that the optimal conditions exist for the subsequent steps in the process before proceeding. In this case, we ensure that the vehicle's velocity or speed is 40 miles per hour or less to help reduce motion blur. And also, if the detected pole is within 10 to 15 meters of the camera, such that we're close enough to acquire detailed images of the pole top components. If these conditions have been met, we move on to step 4, where we trigger a global shutter camera and capture a series of frames. The resolution from this camera is much higher than that of the stereo camera, and the lens and camera combination are designed to minimize motion blur and distortion, so we're providing the highest quality input to the downstream models. Then in step 5, we run our component detection model on the frames from the global shutter camera, and its task is to identify each pull top component, so each mushroom insulator, each transformer, each cutout, etc. And then last, in step 6, cropped images of each component are sent to the issue detector, which will identify defects like corrosion, leaking dielectric fluid, and blown cutouts. So we hope that this provided you with some insight as to how you might be able to achieve distribution inspection at scale while mitigating some of the risks associated with doing so. Thank you, and back to you, Eric.
Thanks very much, Chris. Excited to see this project. It's a project EPRI and First Energy are working together to test this technology. So really excited to see this coming together. So thanks again, Chris. Reminder to put questions in chat for Chris and for all the presenters here today. So next up with us is Junaid Farouk, Strategy and Business Development at Datch. Junaid, over to you.
Hey everyone, how's it going? Junaid Farouk here, Head of Strategy and Business Development here at Datch. Yeah, I'm happy to be presenting to you today. So yeah, a little bit of background about Datch. Basically, you can think of Datch as basically an Alexa or a Siri, right? Kind of like you have at home, but really geared towards the industrial workforce. So at Datch, we're, oops, 1 second. Apologize, my clicker isn't working. Can we forward the slide? Thank you. So yeah, my background, I come from the utility space, and also I used to work at Tesla for a little while. Basically, our company is made up of a lot of engineers from a variety of different industry verticals. And you know, the whole goal of Datch is essentially to, can we go to the next slide? Is to be a voice visual intelligence platform for an industrial operation, basically. Here at Datch, essentially, the goal of the organization, can we go to the next slide? Yeah, so the goal really is to solve this issue of this excessive time that's spent on administrative tasks from the frontline worker, and give them a more natural way to enter information and submit data to the system. And so there was a study done a few years ago, essentially, that, we basically are finding that a lot of organizations, they have the current ways that people are reporting are inefficient, they're slow, they're tedious, and they're really prone to a lot of error. You know, writing on paper, there's a lot of pathways where you have we can have errors and inconsistencies in recording that data, which can lead to an inefficient and potentially risky operation. When you talk about, you know, not getting enough safety reports coming in, that sort of thing. And you know, there was a study done a few years ago that found basically across all industrial enterprises, about a quarter of all time spent on industrial processes is recoverable. And this is really where Datch is designed, is to focus on using voice commands and conversation technology to remove that waste and really humanize the reporting process to make it a lot easier for workers to be submitting information, but also recalling it in real time without stopping their work. And I think this is really valuable for a lot of organizations, is having people not having to spend time on administrative tasks, which really nobody likes to do. Even the worker themselves, they don't want to be spending time going back to their truck or going back to the terminal and entering information that they may have forgotten. So you're really getting sparse information. And really that's what Datch is designed to be, this conversational AI assistant where the person can just have their walkie-talkie on. They can be recording whatever they're doing. They could be, you know, interacting with machines as well as other people, but recording all of that rich, structured information. And what Datch is going to be doing is structuring that information and standardizing it into a format that's useful for the company, where the company can do trending, analysis, risk modeling, that sort of thing. And so at its core, what Datch is a real-time conversation knowledge capture engine, right? So in this example here, you basically have a dialogue of a person speaking very naturally about what exactly they're doing. In this case, and then what Datch will be doing is using its natural language processing engine, its intention engine, and also the integration element of it to structure and formulate information in a way that the company requires. So in this case, you have this dialog: "Hey Dash, create a maintenance log for valve 233 on 123 Main Street." So what Dash is going to do is it's going to identify informal words and associate those with formal metadata. And this is where it's really important for companies. Why it's important for companies to have this information is because people, at any organization, you have all these sorts of company jargon, lingo, different names for different assets. Blue transformer, red pole, whatever. And Dash is going to be able to translate those into a very specific, complex metadata asset ID information. And so now you can do a bunch of different stuff with this data, basically. And so going through this, on the right side, you have basically what the company is requiring as a form. And on the left side, you have the person speaking naturally, and Dash is going to import all of the relevant information into these right fields, and they can upload videos or photos or whatever they like. So there's basically Dash is a voice layer on top of any ERP system. We work across basically any sort of process that currently exists. And we see a lot of use cases in maintenance, specifically right now. It's really good for inspections. So you have like walkthrough inspections. Dash can speak back to you and talk you through an SOP, for example, or some sort of a job, and really be a sort of a true assistant as in the field. And while you're working, you can just have your headphones on. You don't even have to look at the phone. And so from the technology standpoint, there's a lot of stuff happening in the background, right? It's quite, the interface may seem quite simple, but every sentence that's said is actually fed back. Any sort of correction that is done is fed back into the system, and it's learning. This is really crucial for different accents. When it's noisy and when there's company jargon involved, the person can really go in there. If it picks it up wrong the first time, and it may pick it up wrong. And in this case here, you have hydraulic press 3. I might have meant to say hydraulic press 33, right? But the person can go in and just correct that, or they can play back the audio and be like, why the hell did this come out so wrong? And then they realize, oh, it's very noisy out here. So maybe I'll go to Require Replace and record that. So they can do that correction right there, knowing that this is going to be, the next time they say it, it'll learn, and it'll be a lot more accurate next time. Also, all of the phrases are recorded on MP3 locally. This is really useful for our offline capability, which is a really high in-demand feature right now. So I'm going to play a couple of videos here and show you an example of Dash in action. Now, again, Dash is really, like I said, very adaptable to basically any process. These are just some that we have to show you. So this is going to be of a maintenance log on a specific asset.
Create a maintenance log for spot welder line 1. The job took 45 minutes and was completed by Ben Purcell today.
Please describe the problem.
There was hydraulic fluid leaking from a crack in the metal on the side of the drill.
Please describe the work that was carried out.
I completed a spot weld and sealed the metal crack that stopped the leak.
Make a change or save.
So I'm just going to go in here and make a small correction.
Save the maintenance log?
Yes.
Maintenance log created.
So, okay, so what's happening basically is I'm speaking and I'm basically saying I'm basically entering information in this maintenance log. Then Dash is recording that. And what it's doing is it's pulling up a lot of information from a long sentence, right? So what I said was, hey, Dash, create a maintenance log for spot welder line 1. The job took 45 minutes and was completed by Ben Purcell today. And what Dash did was pull all of the information, pull any sort of relevant information from there that were associated within in this particular form, like duration, time completed by, obviously everything is going to be timestamped to the second. But yeah, and populate these, and any sort of missing fields will also be populated based on what I said. So I'll walk you through this next one. This is going to be of a hazard report. Basically, it's like if you think of it as like a safety report. I come across, I'm walking through the factory, I see this this rotor assembly and it's vibrating, right? So I want to put in a hazard report on this.
Record an issue for the rear left brake rotor assembly.
Issue record assigned.
Set the issue.
What's the issue?
The test rig is overhanging on the platform and is a tripping hazard.
Got it.
The rig is also vibrating due to loose bolts.
Got it, thanks.
Set the action.
What is the action?
Recommend replacement of the rotor by next week.
Action added.
Also recommend a quarterly inspection be conducted by the maintenance team.
Got it.
Export.
So this, essentially, if you think about safety reports, they're very annoying. They take a long time to do, but essentially someone can do this in about 15 seconds. And then this last one is Dat's really good at searching records. So really diving deep into databases. So you can say, hey, Dat, search work orders, for example.
Search work orders.
Say the work order or filter.
Filter by work orders with the user status WOCO.
Say the work order or filter.
So I'll select the second work order here. Create history write. So I conducted the rotor speed calibration and noticed a vibration issue.
Got it, thanks.
The calibration readings were successful.
Got it, thanks.
Recommend a quarterly inspection be done by the maintenance team.
Got it, thanks.
So I notice here that there was a mistake in the first phrase. So I'm going to go in there and fix that. So this should be rotor speed. I could also play that back if I wanted to. Set user status to initiate.
User status set.
Export.
So I don't have much time here, but yeah, happy to answer any questions on this. We're pretty excited, and there's a bunch of different applications that I can talk through and we can discuss afterwards. And but yeah, thank you so much.
Thanks, Junaid. Really excited to see this worker productivity solution and test come to play. We'll be kicking off this project next week. Our AI team is working with Datch and Con Ed, testing this technology out. So yeah, really excited to see it. So as a reminder, put questions in the Q&A on your Slido platform there. Next up is Nick Ferguson. Nick is a principal consultant working with Live.io. Live.io is a really interesting one. They were in our first cohort in 2019, focused on the use of satellite imagery for vegetation management. This year, we're working with them on satellite imagery around rapid assessment of storm damage. So, Nick, over to you.
Great stuff. Yeah, thanks, Eric. So as Eric mentioned, I'm Nick Ferguson, principal consultant at Live.io. I've worked around the world consulting with electricity transmission distribution companies, and for the last 7 years, I've been based in North America, formerly Senior Vice President at Trimble Inc., responsible for rollout of operational programs to utilities based on geospatial technologies. So yeah, delighted to be here today to present the work we've been performing with EPRI. And in simple terms, we're jointly investigating how radar imagery acquired immediately following a storm event can help ease the tragic effects of the storm and aid coordination of efforts on the ground. So let's start with a brief introduction on who we are. Okay, so yeah, Live.io is a satellite data analytics company. It actually originates in Germany, although now it's based throughout North America and Europe. We monitor infrastructure around the world and keep it operational. So this includes electricity transmission distribution, but also midstream pipelines and the railway network. We do all of this from space. We identify where external threats may compromise the integrity of these networks. And we're able to do this as there's been a revolution in the past few years in Earth observation. There's now many more satellites in orbit, monitoring every single place on the entire surface of the globe. The issue is that there are many different satellites out there, and the data that is produced by all of these satellites, as you can imagine, is very difficult to analyze, especially at a large scale. So what we do is we translate satellite data end to end, meaning we take the satellite data from a multitude of operators and satellites, we harmonize all of this information via API, register it in our database, apply the AI, and at the end of the process, we identify the information that is required or which is needed by the utility to make better business decisions, which of course will vary based on their operating context, but to act quicker, more efficiently, reduce operational expenditure, etc. So satellite data has this huge advantage. It can monitor extremely large areas, it can recall data from the past, and it can monitor things in the instance of a moment. And to demonstrate this to you, at the beginning of this year, we analysed the entire US transmission network with regards to external threats posed by vegetation. And this is all thanks to satellite data, AI, and the advent of large-scale parallel computing. Therefore, when we think about the application of satellite data for infrastructure monitoring and specifically electricity transmission distribution, there are lots of things we can do, including the likes of cycle trimming and danger tree identification for utility vegetation management, which is, we all know, is one of the largest operational line items for a utility. We've already investigated cycle trimming, as Eric mentioned, in another earlier joint project with EPRI. So today we're looking at a new project with EPRI, and we're going to take a deeper look at what satellite data can do for post-disaster assessment, with a particular focus on post-storm assessment. So imagine a scenario where there's a tornado or a hurricane or a blizzard approaching the service area of a utility. The utility potentially has tens of thousands or even thousands of miles of overhead lines. Although a utility may know the progression of the storm and where it struck, often they don't know exactly where they have to go in the immediate aftermath. And this situation can persist potentially for a day or more after the storm. At present, disaster monitoring and recovery work is based on prior knowledge, assumptions, and the deemed priority over which parts of the grid are more critical than others, and so less so by information which has been gathered in the immediate aftermath of the storm. And it's, of course, difficult to do that with boots on the ground, and there's IoT sensors out there, but typically they wouldn't cover every square yard of the network. So furthermore, imagine that after a storm, you most likely have clouds in the atmosphere obscuring the line of sight between optical satellites and the transmission distribution network, or perhaps it's nighttime. And these conditions prevent optical satellites from taking images. So this is where a new type of satellite sensor comes into play, radar satellites, and specifically synthetic aperture radar. So radar satellites can capture images independently of cloud cover and lighting conditions, meaning they can function at day or during the night. And the same satellites can be tasked to cover large areas at a lower resolution or used for hotspot analysis for specific localized areas at a higher resolution. And because radar satellites have all of these advantages, as you may have seen in the media right now, there is a whole bunch of startup satellite companies that have developed and launched new radar satellite constellations. And there's also the existing players in the market that tend to have the larger, more exquisite, more expensive satellite radar capability. So the project with EPRI, together with AMER and Fortis BC, has so we collectively started a joint project together, which is investigating the following questions. First off, how long does it take to task and capture SAR satellite imagery? What is the time period required to acquire and analyze this imagery? How accurate are the analytics used to detect changes in the right-of-way, such as downed trees and damaged utility assets? We actually completed a project with a similar scope with a European railway operator. So I'll talk you now through the process and how we apply AI to satellite data. So let's imagine a scenario where there's a blizzard. In this case, the German railway operator's territory, the blizzard was approaching fast. What Livio did, and what we'll also do with this new project for EPRI, is that we tasked satellite imagery immediately prior to the storm. We then acquired a second set of satellite imagery immediately after the storm hit. And for sort of general reference, the time between requesting a satellite in orbit to acquire the imagery and having the data in our hands to analyze is as little as 70 minutes. So the question therefore becomes, what can you do with this data? And what we do is perform change detection powered by AI. So we take the pre-storm images, we take the post-storm images, we co-register them, harmonize the data, and then using GAN filters, so generalized adversarial networks, we perform an unsupervised change detection to identify the hotspots. And if you're able to see my slides here, you'll see some gorgeous pictures of this in action. So these hotspots allow us to identify where major changes have happened, which have been most likely caused by the storm. However, one of the unfortunate things with SAR data is that when the data is captured at a large scale, it doesn't offer the resolution required to precisely pinpoint the cause. For example, the damage is due to a downed tree on an overhead line, and therefore prior knowledge is required. So what we do is we produce a heat map, and this heat map contains information on where the changes have occurred, combined with information on where a utility's assets are located. And this helps us to identify potential damage to the grid. So if you do this at one spot, it's not much help for restoring the grid, but when you do it across an entire service area, which may be many hundreds of thousands of square miles, it really helps you to identify the assets and the areas that are most affected. And so during the course of our project with EPRI, we'll evaluate the accuracy of the satellite analytics against ground truth measurements from field trips, as well as other data sets as well. So for example, outage information from the OMS. Our intent is that all of the questions that we laid out at the beginning of this presentation will be fully answered, and that answering these questions is a necessary step prior to beginning a potential operational rollout of the technology. So to summarize then, we're currently living through a revolution in Earth observation data. The sheer volume, size, and frequency at which this data is captured necessitates the use of AI and cloud computing for ongoing monitoring applications. We've performed this at very large scale, including proximity analysis of vegetation across literally the entire US electricity transmission network. And we're very much looking forward to working on this project with EPRI. So I guess a request to your audience here, we'd love to hear from you on what you'd like to do with satellite data and AI within the context of utilities and electrical networks. And on that note, I'd like to say thank you very much for your time. Feel free to ask me any questions in the chat bar. You can also contact me in the absence of a slide here. I'll just give you my email address. It's nick.ferguson, Ferguson, at live-eo.com. So nick.ferguson@live-eo.com. Back to you, Eric.
Thanks very much, Nick. Really excited to see this project. As you can imagine, in our artificial intelligence work, imagery analytics is quite popular. As we mentioned, the first look we did with Live.eo is around vegetation management. That's an ongoing business for them that they're doing really well with. We started with I think SRP on that one in the test back in 2019, and really looking forward to this project with Ameren and with Fortis BC around storm damage assessment. The next presentation is Vikyat Chowdhury. He's co-founder and CTO of Buzz Solutions, also an imagery analytics solution that we're working with. So Vic, over to you.
Thank you, Eric. Great to be here, everyone. I am Vic Chowdhury, co-founder, CEO, and CTO at Buzz Solutions, where we provide actionable insights and analytics for grid inspections. So today I wanted to highlight our Power AI system, which is an end-to-end digital AI automated system for grid infrastructure inspections using aerial vehicles. So just a little bit about Buzz Solutions. We launched as a company in the spring of 2017 from Stanford University, and commercially deployed our technology and validated our technology in 2019. We are funded by strategic venture capital firms, have been showcased in major media outlets such as Forbes, Wall Street Journal, Power Grid International, T&D World, and others. Currently, we are working with multiple utilities across US on the East Coast, in the Midwest, also working and engaging with utilities in Canada to help them inspect their power lines in a much better way using drones, helicopters, fixed-wing aircraft, and then providing them a software and AI solution to manage and process all this data to generate actionable insights. Just to highlight, our end-to-end digital automated inspection system provides a secure and scalable visual data management for utilities. It also provides AI-based visual data processing, analysis, and reporting for actionable insights. And lastly, we are going into predictive space, where our predictive asset management system provides predictions and forecasts for these insights, which takes the industry from being reactive to the problems to being more proactive and predictive in their approach for their infrastructure inspections. So to highlight, we work with drone, helicopter, fixed-wing aircraft, these kind of aerial vehicles that are out in the field doing frequent inspections and capturing aerial visual data in the field. Once they've captured all this data, we ingest that either through connecting with utility data infrastructures using our API connectors, or through direct access to our software platform to either utility personnel or these drone and helicopter service providers. Once that data has been imported into our platform, the users can then manage this data in one place and collaborate over projects, create inspection reports, do processing in one single software platform, which is our Power AI platform. So after the data ingestion has happened into our central software platform, the users of our platform can process all this visual data using our integrated and trained computer vision algorithms. Our proprietary algorithms detect all the major transmission and distribution assets and asset anomalies with varying degree of severity. So just to name a few, insulator damages, different kind of insulators, glass, porcelain, polymer insulators that are on transmission assets. We also detect cross-arm damages or wood pole damages, woodpecker holes on low voltage city lines. So all those anomalies and assets are detected with our pre-trained computer vision models based on the data sets that we have collected by working with either utilities or these inspection providers, which are drone or helicopter providers that are already capturing data in the field. Once the data has been processed by the users of the platform and subject matter experts, we highlight a system called Human in the Loop, which encourages or leads to an active learning approach of our models. So subject matter experts and users have the power to go in and kind of create their own labels, and they can even update the labels that are predicted by our AI algorithms, computer vision algorithms. And what that leads to is all that information is then goes back to our backend, which kind of reinforces the models to penalize them when they're wrong and reward them when they're right. And that does a continuous learning process for our algorithms based on a subject matter expert feedback. And that is pretty critical as we ramp up our deployment and adoption of AI models for various utilities. And we see significant progress even within a few weeks and in a month's time, and the data becomes much more personalized. The models become much more personalized, robust, and accurate for those customers. And once this process has been done, we want to visualize these results and export them to utilities, legacy softwares, and applications such as work order management systems or GIS systems, where tickets can be created to take actions for maintenance, repair, replace in the field around these lines and electrical infrastructures. So just wanted to highlight the next stage or evolution in this is our predictive asset management system. Using historical data, we want to move towards being predictive by developing this predictive asset management system that uses various other data sources. So line data, climate and weather data, and then again, the data captured visually by aerial vehicles. And we feed it to our predictive insights engine that is able to forecast and predict the health of the line and the asset into the future based on historical trends that the models are seeing in the predictive insights engine that we are developing. So this is a work in progress. We are working with utilities and capturing historical data to build this kind of system that will help them in kind of understanding the health of the line and asset into the future, so that they can take necessary steps before any incident happens in the field. So just to highlight at the end, using this end-to-end system, utilities can make their inspections and maintenance operations much more efficient and streamlined due to cost and time savings for analysis of this data that is captured visually in the field. It is also a scalable approach to manage infrastructure data, as we see utilities capture much more data in the field now, mandated to do much more frequent in-field inspections. It also provides cadence for automation for massive data processing use cases. It is able to generate actionable insights, and finally becoming a predictive solution for not only detecting faults, but also predicting statistical likelihoods of faults or hotspot areas in the future for the utilities. And that's a little bit about us. We are excited to work with EPRI and their utility partners for the upcoming projects and provide our solutions to help them manage or inspect their power lines and power infrastructure in a much more streamlined and efficient manner. But feel free to reach out to us. We are Buzz Solutions. I will take any questions or feedback or comments. Thank you so much for your time. Back to you, Eric.
Thanks, Vic. Really exciting stuff. Yeah, so this one is a project we're doing with Newfoundland Power. Kicks off in just a week or two from now. So really excited to see the results of this one. It's high on the list of all of our utilities urgency to really understand how to better use unmanned aerial systems, image analytics, that sort of thing around our infrastructure inspection. Last but certainly not least, one of our projects from last year, we were super excited about it. It's really, really cool to see kind of the progress this company has made since we worked with Myrna and her team at RWI Synthetics. So next up with us is Myrna Bittner. She is CEO and co-founder of RWI Synthetics. Myrna.
Really enjoying seeing the projects from this year. I'll start at the beginning of our presentation. There we go. So my company, RWI Synthetics, was part of the cohort last year, and you'd think that last year was kind of set up to kind of highlight what we were good at. We really use artificial intelligence and a lot of different aspects of artificial intelligence to model unprecedented scenarios, scenarios where there is little to no data or incomplete data. And we really kind of use the scenario-based artificial intelligence to dial forward and look at things like resilience and impact calculations. And I was looking at the reverse pitch requests, and last year was really unusual, and it was great to do a project, that highlighted our capability of tackling things that had never happened yet, and really being able to inform through synthetic modeling. But today, I think there is a lot of more everyday use cases also for what we do that I heard in the reverse pitch. So TVA was talking about looking at assets and how to forecast and predict things that were novel scenarios, even in gas turbines and development with EPRI. But also there was some really big questions like LADWP, who are looking at how do we plan for, accommodate, manage, massive EV adoption. And these are some of the scenarios that are particularly kind of appropriate for synthetic modeling. So synthetic modeling you can think of as kind of SimCity, except for real. It's a really rapid modeling technique of interconnected models that can include everything from technologies that exist, those that are anticipated, as well as infrastructure that's in place. They're geospatially accurate models. And to layer on things like human behavior, so psychosocial behavior, reactive responsive behavior, and really be able to dial forward those scenarios and produce the data and then actually make the analysis possible. These are some of the areas that we exist in. The future of electrification and utilities is really one of them. With EPRI, we got to kind of expose and explore both disaster response and preparation, as well as the future of electrification. So inflect in our disaster response scenario things that might be considered investments and how those would impact the community under various scenarios. But as well as we're finding out today, EVs form just a huge part of that, the future of electrification and landscape. And we've got to figure that out together, and that this is a good environment that we're working on projects in. This is a bit about our team. So like Eric was talking, it's neat to see the progress. We're really enjoying the progress we've made in working with EPRI. One of those kind of advances in what we were doing is we are working with the National Science and Research Engineering Council of Canada on a COVID-19 resilience and cyber outage project, so Black Sky. as well as we were able to collaborate with EPRI and win a spot in the U.S. Air Force's AF Works showcase. So reimagining energy through what we were calling a tool called a synthetic base. And that was a really exciting win for us. And then we have really had it just finished developing an extensive mobility catalog, and we're able to explore that with the City Architecture of Tomorrow Challenge, as well as becoming one of the SET 100, so top companies in energy and mobility in the world. And once again, I'm going to go into a little bit more detail just to give you a really good example of what we did with EPRI during the project. So this is it's a type of digital twin. It's a digital twin that's got synthesized assets so that are accurate. It's hyper-localized, so population, utilities, infrastructure, policy are all a part of that landscape in that digital twin. And we can add, most importantly, to all of that technology and people and asset, our people, sorry. And here is the project. Here's what that looks like. So we can create a model. This was done with EPRI and Salt River Projects, was our utility project partner last year. We were able to create an area of Phoenix and Tempe for study. All of the people, the businesses, their consumption patterns dialed forward under COVID as well. We were able to synthesize those, and then we were able to turn the lights out and really kind of look into the interior detail of how investments in resilience on the utility side would make a big difference for human impact, their customers, their forward-looking engagement, their willingness to pay, how they valued reliability, and look at those throughout that outage. Behind this is deep tech. So I've been in artificial intelligence since the 1990s. And so we pull a lot of that together in how we interconnect these models, the types of models that we use, and even how we synthesize things like grid assets and the population in particular areas. And once we mix those all together and interconnect them, we end up with these massive kind of living labs that we can use to explore the scenarios. And we worked through a process of validation, so validation of baseline today, which we were able to do quite uniquely with Salt River Projects because of the condensed timeline. We weren't able to access data. And this was a good thing because we now have, can highlight that even in highly regulated environments where they have issues with providing access to data, even around power consumption data or meter data, that we have the ability to synthesize that data without ever having access to that data and then validating it with the utility. So that was an important part of our project. And again, we're really looking at these environments as being additive, as producing, kind of very hyper-localized information about scenarios so that it can be actionable. And to do that, we always bring the people. So we think the people are a huge part of any utility landscape, and their behavior is shifting. And through decentralization and the impact of their activities on the edge of the grid, and the engagement that we're going to require from those people as we move forward to manage things like electric vehicle charging behavior and smart meters and time of day usage. It's really important to get to know these people and get to know how they're reacting and responding. So we pay in extraordinary detail to synthesizing the population based on domain expertise, all kinds of research. And we use our neural net filtering process to actually apply that to a novel population that's hyper-localized in this area. And in this project, we were able to bring in surveys, so industry surveys from the Smart Energy Consumer Collaborative. And we were able to apply those surveys and that survey data to households that were actually in the area. And then that enabled us to survey the population every 15 minutes and find out how their responses and their reactions were actually changing during the outage. And then we were able to really kind of dig into discontinuous aspects of human behavior, discontinuous aspects during the outage, about trust, about willingness to pay. and look at things like the delta graphs. So differences, we could make different runs, we can make changes in those runs, and we could understand what had changed depending on different investments that the utility company was making. One of the most profound ones was in communications during the outage. And because we can strap on and these environments are very extensible, we were able to add all different kinds of industry calculations, as well as calculations from surveyed businesses about what their losses were like. So we can extend kind of beyond what does an outage cost the utility to how does the outage actually that community, and help them use those calculations when they're making investments and talking to their regulators. And here we can use multiple calculators even for the same thing. So we accessed one of the calculators was from the Department of Energy, and we were able to connect with them and collaborate and include it. And we could see how their online kind of ICE calculator or interruption cost estimate calculator compared in this specific area, so we could localize it specifically for the area. And it's really about time. So because we can manipulate time in these environments, we can fast forward, every 15 minutes for an hour, we can fast forward for a month. We're doing a black sky initiative now where we've had the power out for weeks, and we're actually beginning to look at what happens in the population. And GHG is a big deal for a lot of utilities. And this was an interesting, because we're dealing with lights out, it was an interesting kind of perspective on being able to apply the backup and auxiliary power as it is in the area, and then watch as the different types of backup power and generators attached to different businesses with different consumption patterns, how and what those GHG implications would be in an area that's really sensitive and really trying to manage and maintain their GHG emissions. And then we can start looking at the differences. So the deltas in when we inflect different investments from the utility, how that would actually impact the GHG emission reductions during those outages. This is an example of some of the fun we get to have with the visualization side. So really, because we are looking at geospatially accurate areas and we're dialing forward the future, we think the data gets really quite complex. So it's fun to be able to include these in really unique and compelling visualizations for our customers. This was for the AFWorks synthetic base project with EPRI as our subject matter experts. And here's some other examples. So we do, kind of different specific projects and interfaces on top of the data, the massive amounts of data that come out of these synthetic models. And I'll finish off with, this is kind of our sweep of value propositions and really why we think that, not only should we be looking at data from today or that was created yesterday and try to help it, predict tomorrow, but there's also, as we've learned lately, this massive opportunity to be able to dial forward in the world of what ifs. And we believe that in order to do that, you need to take a really holistic approach, be incredibly interconnected, make sure that there's people in those models and dynamic things and entities like people. Really kind of include as many experts as possible and be data powered, but not necessarily data dependent. Thank you, everybody. Thanks, Eric.
Thanks, Myrna. This was a really exciting project for us that we did last year, just the integration of the behavioral models and those sorts of things. So I'm really excited to see the projects that we're running this year. So for those in the audience, we are pretty much out of time. I might squeeze one question in, but before we do that, if you're interested in learning more about the project Myrna ran with us in Salt River Project last year, or any of the other projects we ran over the last 2 years, go to labs.incubatenergy.org. You can check out recordings of those, decks for those presentations. Keep an eye there for these projects that are running this year as well. If you're interested in seeing how these projects that you've heard from today and others go for 2021, make sure you join us for Demo Day, October 19th and 20th with EPRI for our Incubate Energy Labs Demo Day. We have a couple questions coming in, but we are a minute left. So I think maybe what I'd ask is if those questions are out on the platform, ask our panelists to go back onto the Slido platform and engage with the people on that platform. So with that, Chris, Jade, Nick, Vic, and Myrna, thank you so much for joining us today. Really exciting projects, really great applications of artificial intelligence in the electric power industry. Hannah,
Eric, all right, guys, we are going to head to a break now. We will be on break until 1:30 Eastern time. We will be back here at 1:30 for another response to a reverse pitch. Thank you very much.